Hi everyone. So today is Wednesday, December 7th. And then today we will talk about sessions 8.2 and we might start 8.8 lectures a little bit. And then Friday we'll continue to talk about session 8.8. Tonight we have review session from 8 p.m. to 10 p.m. Okay, everybody? All right. So our final exam is on next Wednesday, 1 to 3 p.m. in this room. Today we will go over the quiz 8 and also the mistakes. So everything, the practice exams, exam correction and records, and all your homework must be submitted by this Friday midnight. Okay, everybody? Because after the Friday, I will calculate your grades. And once I finish calculating your grades, I will email to you to help me to check. Okay, and also all the extra credits. If you miss no more than 2 classes, then you receive 1% attendance bonus. If you show me your notes, you receive 1% note-taking bonus. And also the evaluation. Our response rate is 67%. That means everybody will get at least 0.2% extra credits. We just need one more student to fill the survey, and then we can reach 70%. Then everybody will get 0.3. So if you haven't filled the survey, please help me to fill that out. I have some classes already have 100%, so they can get over 90% and include 90%, and everybody can get 0.5% extra credits. Okay, and thank you. Your comments are so important to me. I'm so happy to be your instructor this semester. So let's see. Bashu. Okay, quiz 8. So this is our last quiz. We dropped 2 lowest quizzes and we dropped 6 lowest homework. Okay, so you can go to Blackboard and you can check my grades and see how many percent you have gotten so far. Okay, so homework average, quiz average, and self-assessment average. Your practice final exam is due on the final exam dates. Okay, but except that, everything else you must submit by this Friday. Is that clear, everybody? Yeah. So after you finish your final, I will grade it, and then I will post your grades the next day. And at that point, there's nothing we can change the grade. Okay. So you earn the grades. Your performance decides what grade you earn. Right. Okay. Let's see. All right. So, okay. Quiz 8. Solution. So problem 1. Find all the solutions of this given equation. So here we have cosine square and sine x. Okay, so we change the cosine in terms of sine. Cosine is 1 minus sine square. So we replace cosine square by 1 minus sine square. And then we combine the like terms. See, 1 and 5 give us 6. And then this is minus sine square minus 5 sine x plus 6. We want to make the leading coefficient to be positive. So we both sides multiply by minus 1. And then this becomes positive, this becomes positive, and this becomes negative. So if you are familiar with this quadratic equation, you can factor it. If you're not familiar with it, you can let u be sine x. Okay, so really up to you. Okay, if you're not familiar with it, let u be sine x. Then you have u squared plus 5u minus 6 equal to 0. And then factor it and find the u. Okay, you can either factor it or use the quadratic formula. Okay. And then, you see sine x equals negative 6. That is impossible because sine and cosine, they are bounded between -1 and 1. Therefore, you get negative 6. That's impossible. Because it's right down, impossible. So no, we don't consider that. And then here, sine x equals to 1. So you draw the graph of sine equals 1. That means x must be pi over 2. And then because it's 2 pi periodic, we add 2k pi, where k is an integer. So this is problem 1. Any questions on problem 1? Are we all good? Yes? Problem 2. Okay, so this problem is already given as 4/3 minus 7 pi over 4, right? So then you can use the sine difference angle, right? Difference formula. So that is sine A minus B is sine A cosine B minus cosine A sine B. And then here, 4 pi over 3. This is in quadrant 2. So this is like pi plus pi over 3. For quadrant 2, sine is negative. Sine is positive. Oh, sorry. Quadrant 3. Yeah, quadrant 3, not quadrant 2. Quadrant 3. So the sine is negative. Okay, and the reference angle is pi over 3. So this is negative sine pi over 3 is root 3 over 2. Thanks, everybody. And here, this is 7 pi over 4. This is the 4 quadrants. You see the 4 quadrants, the cosine is positive. And the reference angle is pi over 4. Cosine pi over 4 is root 2 over 2. So this is root 2 over 2. And here, cosine 4 pi over 3. This is in quadrant 3. Cosine is negative. And the reference angle is pi over 3. So cosine pi over 3 is 1/2. And then this is negative 1/2. And then the sine in the 4th quadrant is negative. The reference angle is pi over 4. Therefore, sine of 7 pi over 4 is negative root 2 over 2. So negative, negative, negative is negative. So a negative root 4, square root of 6 over 2 over 4 minus root 2 over 4. We can combine them. We get negative square root of 6 plus square root of 2 over 4. So far, so good, everybody? So that is our quiz. Now, let's look at the mistakes. So, quiz mistakes. Okay. Wow, we have 90 pages of all the mistakes. Okay, so when you when you study for the final exams, you review all those practice exams and the actual exams, your exam corrections, and then you also review all the mistakes. Okay, so I have pre-screened all the quiz mistakes and all the exams common mistakes for you. So it's good to review those mistakes and remind yourself, don't make the same mistake again in the final. Okay, here the student combined it and got 19 pi over 12. And then the student used the double angle formula to solve. Yes, we can do that. But it's just here. The 19 pi over 12 is 19 pi over 6. Bless you. 6 over 2. Okay, so this is 6, not 12. Okay, and then you can use the double angle formula. The plus or minus, it depends on this angle because this angle is in which quadrants? So when you subtract 2 pi, let's see. This is when you subtract pi is 7 pi over 12. 7 pi over 12. So this is in quadrant 4. In quadrant 4, the sign is negative. Okay, and these students, okay, have a longer, more detailed solution. And yeah, this is not a mistake. I'm just showing you this is another way of solving this problem. Yes. So the student combine them and get 19 pi over 12 and recognize this is 19 pi over 6 over 2, and then you can use the double or half angle formula. And then we get one minus cosine 7 pi over 6 over 2, and then we realize that is square root of 3 over 2, and then eventually you get the same answer. But you can tell which method is easier. This method, just 3 lines, but this method, much longer. Okay, so they both work, but this method will take more time. So I suggest you to use this one. Okay, but this is good. This is another way to do that. And then here. Okay, so here the mistake is don't divide it by negative 5. Because if you divide it by negative 5, the cosine square, you also need to divide it by negative 5. And then you introduce fractions. We don't want to have fractions. Okay, so don't divide it by negative 5. Move all the terms to one hand side and factor. Okay, so actually we were giving all the terms on the one hand side. That's great. Don't move the constant to the right. Okay, so when I solve the equations, I try to write down the steps. I say move all the terms on one hand side and factor. So I recommend you to also write down the steps. Remind yourself what you are doing, because it looks like the student kind of get lost and don't know what to do. Okay, so review the steps. Okay, review the steps, the process. I put it in your class notes. Move all terms to one hand side and factor. Okay. But so and this problem, the answer does not support the work. Okay, so you need to show your work, and your work must support your answer. Otherwise, you don't earn the points. Okay, so then see sine negative 5 pi over 12. How do you get this number? So show your work. Okay. And then this problem makes the zeros. Okay, so and here makes the parentheses, and here makes the parentheses. So try to work carefully. Those small details. Okay, and then here, no f sine negative 6, because the domain for f sine only covers minus pi over 2 to minus 1 to 1. Okay, that's the domain of the f sine. So if sine x is negative 6, that is impossible. Okay, and then here, when you do f sine of 1, you get x is pi over 2. But you know 1 is not pi over 2. So when you write down your work, you gotta be careful. Don't write something wrong. 1 is not pi over 2. You mean comma. X is pi over 2. So x is pi over 2 plus 2k pi. Don't put the sign over there. Okay. What? There's a problem? Let's see. Can we see it now? Okay. Which one? Yes. Okay, now this one. This is square root of 2, not square root of 3. Okay. And then this one. Yeah, perfect. So write down the step. That's good. Write down the step. And then Factor, yes, keep going, factor. See, this is a quadratic equations, right? So we order it so the highest power is in front, and then the constant term is at the end, and then try to factor it. Okay. So when you do your quiz, before you do the quiz, review our in-class notes, because usually you have some similar problems from the in-class notes, right? So review those and then do the quiz. Okay. And here, similarly, we don't have sine -6. Is that clear, everybody? Cosine and sine only covers from -1 to 1. So be careful. And then here also, this is square root of 2, not 3. And then here, trig identity, 1 minus sine square. Okay, no 2. No 2, no 2, no 2. That's why when you factor it, you will have different answers. And also, this is the u, okay? You let, what's your u? U is sine, right? So sine u is 3 over 2. Sorry, sine x is 3 over 2. Oh, yeah, the problem is, if we make that mistake, these both numbers are bigger than 1. So we cannot find the x. Yes, so the mistake will change a lot. Okay. And then here, this is negative. Okay, this is negative. I miss the minus sign. And then here, please don't miss the equal sign, okay? And how do you get pi over 2? So it's better to draw the graph, okay? So to tell me that you know, I can tell from there to see this is pi, x is pi over 2. And then here, see, this is minus, and this is minus. Don't change the sign. And then this minus, so yeah, that's what you say. And in the exam, if you have special angle, like 1, okay, at sine 1, you can tell me that's pi over 2. At sine of root 2 over 2, you know that's pi over 4. So for those special angles, please write down the angle. So don't put at sign of a number. Is that clear, everybody? If it's not a common angle, plug it in your calculator and give me either degree or radian. Is that clear, everybody? So don't give me at sign or at tangent if you haven't finished the problem yet. Okay? Your final answer should be an angle. Okay? It's either in radians or degree mode. Okay, so that's it for the quiz mistakes. Any questions? Are we all good? Okay, so yes, let's talk about 8.2, law of cosine. Do you still remember law of sine? We have sine A over A equals sine B over B equals sine C over C. That's easy to remember, right? The angle you use capital letter, and then the side you use small letters. Do you remember that, everybody? And the law of sine. Last time we used law of sine to help us to solve angle, side. Do you remember that? Angle, side. If you know two angles, then you can find the third angle because the sum of the three angles of a triangle is 180 degrees. Yeah. So angle, side, we can use law of sine. And last time we also did a side angle, but that one is ambiguous because you can have a lot of different cases. So you need to draw the picture. Depends on the angle is an acute angle or an obtuse angle. Right, everybody? So law of sine, we can use it to solve angle, side, or side, angle. Today, we're going to learn law of cosine. So law of cosine, we know, let's see. Okay. So this is law of cosine. So A squared equals B squared plus C squared minus 2BC cosine A. So if you know two sides and the angle between them, then you can find the opposite side by the law of cosine. Is that okay, everybody? By the way, not law of sine is easy to memorize, so I don't give you formula in the final exam. The law of cosine, I will give you the formula in the final exam, so you don't have to memorize. You just need to know when do we use it. When you have the two sides and the angle between them, when you know that, then you find the opposite side by the law of cosine. So a squared is b squared plus c squared minus 2bc cosine a. Okay, everybody? Mm-hmm. And how about b? Okay, so if we know the side c and a and the angle b, then b squared is c squared plus a squared minus 2ca cosine b. Okay? So you use law of cosine. If you know two sides and the angle between them. Okay, so we can summarize. Okay, so you use this set of formula if we know two sides and the angle between them. Okay, and we want to find the opposite side. So you can summarize this as SAS. We know two sides and the angle between them. So side, angle, side. You use this set formula. And then you use these formula if you know all three sides. And then you want to find the angle. Okay, so you use this formula if we know all three sides and we want to find an angle. Okay, so cosine A is b squared plus c squared minus a squared over 2bc, and also like these ones. Okay, so you want to find an angle. So we can call this case is side, side, side. So we use law of cosine to solve side, angle, side, and side, side, side. Is that clear, everybody? Mm-hmm. The proof, because we don't have enough time, so we don't prove it in class. But it's in your textbook. It's also in the Mobius lessons that I posted in Blackboard. So you can look at the proof there. Now let's see, how do we use law of cosine to solve our triangles? Okay, so this case, side, angle, side. So we have two sides. This is 80, 60, and the angle between them. Okay, that is 34. Then what is that angle? 180 minus 34 is 146 degree. Yes, this is 146 degree, right? Yeah, the first step, we find that angle. And then let's give it some name for the vertex. Let's call this C. Let's call this A. Let's call this B. We use capital letter to denote angle, and we use small letter to denote the sides. So this is opposite to B, so side B. This is opposite to A, so we call it side A. And this is opposite to C, called side C. Okay, so now let's see. We can find C, the side C, by law of cosine, right? Okay, so side C. Okay, that is a squared. So side C, we're using this formula. C, oops, it's shift. Okay, maybe I shouldn't redraw it. So c squared is a squared plus b squared minus 2ab cosine c. A squared plus b squared minus 2ab cosine c. Yes, it's always cosine because it's law of cosine. Okay, the trig function is the cosine. So therefore, a is 60. So 60 squared plus b is 80. 80 squared minus 2ab. A is 60, b is 80, cosine c. C is 146 degrees. Right, everybody? Okay, so what do you get? Put this in your calculator and give me 4 decimal places. Okay. You might have a big number. What do you get? Yeah, everybody take out your calculator and put that in. It's also very important to practice how to use your calculator. What do you get? 1, yeah, 0.7607. Thank you. So this is the c square. Well, then c is then the square root of this number. Do you know your calculator? You can put square root and then there is a answer. So answer, do you see the button on your calculator? The answer? Yes, you can put that in and it's more accurate. Give me 2 decimal places. What do you get? Thank you. Okay. All right. Oh, let's see. Okay. 134.11. Huh? 0.1. Oh, okay. Let's just keep 2 decimal places. So 0.1? Yeah. Oh, 0. So not 1.1. Okay, 0.1. Thank you. Okay, this is C. So we know C. We know all sides, but we still missing angle A and angle B. Right, everybody? So here we use law of cosine to find small c. But then we want to find the angle A and B. Here we use law of sine to find A or B. Okay, you find one of them, and then the other one you can use the sum of the triangle is 180 degrees to find it. Okay, law of sine to find angle A. Well then, we need angle A over side A equals, because we already know the angle C and the side C, so we want to use sine A over A equals sine C over C. We don't use sine B over B, okay? So sine A is our unknown, and then the side A is 60. Angle C is 146 degrees. And then the C is 134.01. Yes, everybody? Oh, we want to solve for A. See, I can get rid of the 60 by both sides multiplied by 60. Then we have sine A is sine 146 degrees over 134.01 times 60. Okay, what do you get? Give me 5 decimal places. Make sure you're in the degree mode. .25038. Thank you. Okay, so this is sine of A. If this is not a special value, angle value like √2/2, √3/2, and 1/2, then your A is at sine of that number. Give me 2 decimal places for the angle. (14.49 degree). Yes? Okay. Is the next digit greater than or equal to 5? Then we round up. Okay, yeah. Great. Okay, so that is the angle A. Yes. So then the B is 180 degree minus the C. C is 146. And minus the A. A is 14.5. Okay. And what is angle B? 19.5 degree. Okay, great. So we saw this triangle. Okay. Oh, let me make it smaller. Okay. So when we have side, angle side, we use law of cosine to find the remaining side. Yes. And then we use law of sine to find one of the angle. And then we can use the sum is 180 degree to find the remaining angle. By the way, when you use law of sine, you can find the angle A, or you can choose to find the angle B. And then you just do sine B over D. Is that okay, everybody? And you can use the sum is 180 degrees to find the angle A. Okay, so different ways to solve this problems. Okay. Now, side. We use this set of formula. Okay, everybody? So you know side. So you want to find an angle. Okay. So let's see. So let's give it some name. Okay, so let's call this is A, let's call B and C. Then opposite to B is B, opposite to C is C, opposite to A is A. Okay, give it some name. All right. Let's find an angle. Okay, how about let's find the biggest angle, angle C. Yes. So angle C. Then we have cosine C equals, oh, I don't want to flip the page back and forth. Let me just click the final formula sheets. Okay. So this is the formula sheet I will give you. Okay. And also that when you look at the practice exams, you see more formula here. Okay. So yes, this is more formula about vectors and area. Okay, so those formula will be given on the exam. So angle C equals, so we use this one, A squared plus B squared minus C squared over 2AB. Right, everybody? Okay, so A squared plus B squared minus C squared over 2AB. Okay. So A squared, A is 1.1. B squared, B is 2.2. Minus C squared, 2.9. Okay, over 2 times A, 1.1, times B, 2.2. Okay, what do you get? Give me 5 decimal places. Of course, the more digits you keep, then your answer will be more accurate. Okay. So what do you get? Point, oh, 0.51082. Like that? Do you have different answers? What do you get?
I got negative 0.4876.
4876. Oh, what's the next digit?
It's a 0 then a 3.
Oh, okay. That's a 0. Okay, good. Yes. So check your work carefully. Maybe sometimes forget the parentheses somewhere. Yeah, I'm gonna change the word. So the very important thing is, okay, so use law of cosine to find an angle. And very important, find the largest angle. So if you know an angle is the biggest, okay, find it. So find the largest angle. In this case, your angle C is the largest. Looks like it's largest, right? And then, oh, do you see if your cosine is negative means your angle C is an obtuse angle. Okay, everybody? Yes. Because the smaller angles, it must be acute. The largest angle could be obtuse, could be acute angle, right? That's why you look at the largest angle first. If it's negative, then this is obtuse. Okay, the other angles must be acute. Okay, so what is C? So C equals arc cosine negative 0.4860. What do you get? How many degrees? Give me 2 decimal places. Thank you. Okay, so usually when you solve your problems, I want your angle to be 2 decimal places. But I want your the trick function values to 5 decimal places. Is that clear, everybody? Yes. Because then when this number is already so small, so if you only put 2 decimal places, then your angle won't be accurate. It will be off a lot. So that's why you want to keep more digits for the cosine C. Then when you take the arc cosine, your angle will be more accurate. Okay, so this is the angle C. And then to find the angle A and angle B, you can either use law of cosine or you can use law of sine. And which one I like? I like law of sine because it's easier. Law of cosine, yeah. But up to you, okay? You can use law of sine or law of cosine, up to you. Okay, so I use, okay, law of sine to find the other angle. Let me find A, okay? You can find B, okay? So up to you. So many different ways to solve it. Okay, so then we have sine A over A And now we know angle C. Sorry. Yes, sine C over C. Sine A is what we're looking for. Small a is 1.1. Sine C is 119.18 degrees. Sine C is 2.9. Right, everybody? So therefore, sine A, both sides multiplied by 1.1. So sine 119.18 multiplied by 1.1 over 2.9. Put this in your calculator. What do you get? 0.3312? What's the next digits? Oh, 127? Oh, thank you. Okay, yes. Right. Okay, now A is gonna be a sign of that number. Okay, so now for the angle, keep two decimal places. What do you get? 19.34 degrees. Thank you. Okay, once we know angle C and angle A, then the B is 180 degree minus the C 119.18 minus the A 19.34 degree. Okay, what's the angle B? Thank you. Okay. So this is how we solve side. Yes, everybody? Okay. Keep going. Yeah, now we have learned all four types. So law of sine, solve angle side, and side angle. Law of cosine, we can solve side angle side and side. Right, everybody? Okay, so look at this word problem. A ship from point A travels 60 miles due east to point B. Then adjusts its course northward after traveling 80 miles in that direction to point C. The ship is 139 miles from its point of departure, point A. Describe the bearing from point B to point C. Okay, so let's draw the picture. We start with point A, and then we travel 60 miles to east. You know, this is east, and that is north, and that is west, and that is south. Right, everybody? Okay, and so this is point B, that is 60 miles. And then adjust its course northward after traveling. Okay, so we were going this direction. Adjust the course northward after traveling 80 miles in that direction. Okay, so we go this direction for 80 miles. By the way, we don't know what this angle is. Okay, we just adjust it. And then after travel 80 miles in that direction to point C. So this is point C. The ship is 139 miles from point A. Describe the bearing from point B to point C. So we want to fix bearing is, so usually you want to, you're describing as, okay, this is how many degrees away from the north. Okay, so we're looking for the alpha. Is that okay, everybody? Okay, so we want to find out what the alpha is. Well, this triangle, we know all the sides, right? So let's figure out, let's use law of cosine to find the angle B. Then the alpha will be the angle B subtract 90 degrees. Yes, do you see that, everybody? The angle B is your again. Angle B minus 90 degrees is the alpha. Okay, so let's give it some name. This is opposite to angle C, so that's C. 80 opposite to angle A, so small a. And then 139 is opposite to angle B, so small b. We are looking for angle B. So law of, this is side, side, side. So use law of cosine. Cosine angle B is, okay, angle B, a squared plus c squared minus b squared over 2ac. Okay, use that formula. A squared plus c squared minus b squared over 2ac. So let's plug in the numbers. A is 80. C is 60. B is 139 over 2A. A is 80. C is 60. Okay. Plug this in your calculator. Give me 5 decimal places. What do you get? Everybody plug this in your calculator. What do you get? Negative 0.970. Thank you. Okay, so the angle B is a cosine of that number. By the way, this is negative. We know that the angle B is an opposite angle. Right, everybody? Yeah. So put that in your calculator. What do you get? Thank you. Great. So alpha is that number, the angle B, minus 90 degrees, which is, yeah, 76.15 degrees. Okay, so our bearing from B to C is, so this is the notation. You say north, 76.15 degree, adjust to the east. Okay, so this means you start from north and then you adjust 76.15 degrees to the east. So far, so good, everybody? Yes. Okay. Last class. So last class when we talk about law of sine. So I think the word problems we also did. We also have the word problems. Yes. Like here. Yes. Yes. We saw this notation before. So south 52 degrees due west. So which means south. You point to south first, and then you rotate 52 degrees to the west directions. Okay? And then here, south, we rotate 40 degrees to the east directions. So it's always either south or north. And then you rotate to the east or to the west. Is that okay, everybody? Mm-hmm. Yeah. All right. Good. Okay. Here is formula for the area of a triangle. Last time, we know the area triangle. So we use this formula if we know two sides and the angle between them. Okay, so we use this formula if we have side, angle, side. Okay, everybody? So side, angle, side, we use this formula. Today, if we don't know side, angle, side, if we know side, 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 you see what happened? It kind of shifted my, okay, let me put it here. If we know side, 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 we use this formula. Okay. By the way, in the exam, I didn't include this formula, okay, because you can deduce easily. So if you know side, angle, side, well then 1/2 BC sine A, 1/2 AB sine C, or 1/2 AC sine B. Remember that table? This is B. Okay. This is side, angle, side. So today, side, 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 we use this formula. Okay, and this formula will be given in the exam. Okay, so now let's see. Let's give it some name. Okay, let's call this is A. Let's call this B. Let's call this C. Yes, the letter does not matter. You can call them differently. This is A, this is B, this is C. You can call them differently. Okay. So now, S is 1/2 A plus B plus C. A is 2.2 plus B is 1.1. C is 2.9. What do you get? 3.1. Thank you. Aha! So area is then square root of S. S is 3.1. And then S minus A, S 3.1 minus B. B is 1.1. S 3.1 minus C. C is 2.9. Okay, what do you get? Give me okay, give me 4 decimal places. What do you get? Thank you. Yes. So that is the area. So far so good, everybody? Yes. So area of this triangle. If you know side, side, side. And this formula will be given in the exam. So you just plug it in and you can find the answer. Okay. Yes. And then this is the side, angle, side. You need to memorize. Is that okay, everybody? All right. Ooh, okay, so that is sessions 8.2. Any questions about 8.2? No? Yes? No? All right. So, okay, last sessions 8.8. So vectors. Okay, so have you seen vectors in physics? Yes. So you have x coordinate, y coordinates. Okay, let's see. A vector is the name given to an object meant to represent a length. It's called a magnitude or a directions. Vocabulary. The line segment pointing from the point. This is a point 1, 1 to the point Q. This point is 3, 3. Have a length of magnitude 2 square root of 2 and a direction of 45 degrees above the horizontal axis. Okay, so to describe a vector, you need 2 things. One thing is the length, the other thing is the direction. Okay, so 2 things to describe a vector: magnitude, the length, and a direction. And this point P, okay, length and direction. This point P is the initial point of the vector PQ. So to denote a vector, you can use this notation. So P, from the point P to the point Q, and you use the arrow to indicate. So arrow from P to Q. Okay, P is the initial point, and Q is the terminal point of the vector. We usually use the bold face or arrow to denote the vector. Okay, Notice the vector, by the way, so what is the vector PQ? You use point Q minus point P. So you use the terminal points minus the initial points. So terminal point, you see point Q is 3, 3. And the point P is 1, 1. Right, everybody? And when we do vector operations, you use, look at the corresponding coordinates. Okay, you do the operation on the corresponding coordinates. Therefore, the first coordinate, you see 3 minus 1. And the second coordinate is also 3 minus 1. Is that okay, everybody? So 3 minus 1 and 3 minus 1. Therefore, we put 2, 2. For point, we use parentheses. For vector, we use angle brackets. Is that clear, everybody? So for point notation, for points, use parentheses. For vector, use angle brackets. All right. And then notice the vectors from 0, negative 1, comma 0 to 1, 2. Okay. Also has the magnitude of 2 square root of 2 in the direction of 45 degrees above the horizontal. Why the magnitude is 2 square root of 2? Well, look at this triangle. This side, okay, this side is from 3 to 1, right? And the difference is 2. And then this side, also from 1 to 3, the difference is 2. And this is a right angle triangle with the side 2 and 2. Therefore, the hypotenuse is the square root of 2 squared plus 2 squared. Yes, everybody? So, yeah, by the Pythagorean theorem, this is square root of 2 squared plus 2 squared. Therefore, square root of 4 plus 4, square root of 8, which is 2 square root of 2. So the magnitude of this vector PQ is 2 square root of 2. The direction is 45 degrees. You know, how do you calculate the direction, the theta? Well, you calculate the theta by looking at, see, this is opposite, and this is adjacent, right? Opposite over adjacent is tangent. Yes, everybody? Opposite is 1, adjacent is 1, tangent theta is 1. What's theta? So theta is 45 degrees. Are you familiar with the special angle values? So tangent theta is 1, then theta is 45 degrees. Okay, now you realize this vector and this vector, they have the same magnitude and same directions. So they are equivalent vectors. And for vectors, the location of the initial point does not matter. Okay? You just care about the length, the magnitude of the vector, and the direction. The initial point does not matter. So you can move your vector everywhere. Okay? They represent the same vector. Is that clear, everybody? Okay, so yeah, when we only want to talk about the magnitude of a vector, we either put the vector in the absolute value bars. So we put 2 bars. Okay, so this is the magnitude of the vector. So it's like 2 absolute value there. So 2 bars. Okay. Components for a vector. A vector whose initial point is the origin can be uniquely represented by the coordinates of the terminal points v1, v2. This is the component form of the vector v. Okay, so yeah, different notations represent the same vector. Okay. So this is the origin. Okay, and this is the x-axis, this is the y-axis, and let's say this is the v, okay? This is the vector v, and let's say our coordinates. We have v1 and this is v2. So then we can have like the component v1, v2 are the components of the vector v. Sometimes we denote the vector v is v1 times I plus v2 times j, where I is the a vector, okay, and 1, 0. 1, 0 is actually pointing to the x-axis directions. So 1, 0 is pointing to the x-axis direction. So this is the I, okay, 1, 0. And then the j is 0, 1. So you can imagine 0, 1 is here, is pointing to the y-axis directions. They are the standard unit vectors. So therefore, the scalars v1, v2 are the orthogonal and vertical components of the vector v. And the sum v1 times I plus v2 times j, this is called a linear combinations of the vectors I and j. So I and j, they are the standard vectors. Okay, so I is the vector 1, 0, j is the vector 0, 1. Is that okay, everybody? Any vector in the plane can be written as a linear combinations of I and j. For example, I give you a vector 3, negative 4. Well then, it's 3 times 1, comma 0, and minus 4 times 0, comma 1. Your first coordinate is 3. Your second coordinate is negative 4. So that's why this is 3i minus 4j. Is that okay, everybody? Mm-hmm. Yeah. Okay, so the component form of the vectors is with initial point P, which is P1, P2, and terminal points Q, Q1, Q2. So you use point Q minus point P. So, and you do it component-wise. So first components Q1 minus Q1, second components Q2 minus Q2. And then the magnitude. Okay, so the magnitude, you have this side is Q1 minus P1. And this side is Q2 minus P2. Therefore, the magnitude by the Pythagorean theorem is the square root of this side squared plus this side squared. Is that okay, everybody? If the magnitude of V is 1, then V we call it is a unit vector. The length is 1, so unit vector. If the magnitude of V is 0, this is even only if V is the 0 vector. Well, we know a vector has length and directions. For 0 vector, the direction is not defined. It is 0. How do you say the direction? Okay, so for 0 vector, is not defined. Okay, very good. So let's do some practice. Find the component form and the magnitudes of the vectors that has initial points 4, negative 7 and terminal points negative 1 and 5. So we call this is point P, this is point Q, then the vector PQ, you use point Q minus point P. Point Q, negative 1. So look at each component. Negative 1 minus the first component of P is 4. Second component of Q, 5. Minus the second component of P, which is negative 7. What do you get? Negative 5 and 12. Exactly. Right, everybody? Yeah, just look at the components. Second component, terminal point minus initial point. Okay. Then the magnitude. Magnitude is square root of first component square plus second component square. What is negative 5 parentheses square? 25. Do we have negative 25? No, negative 1 square is positive 1. 12 square, 144. That is 169. That is 13. This is familiar with you, right? You did it in the quiz and also in the exam 3. Yes. So this is the magnitude. Okay, so let's continue on Friday. Okay, so see you tonight in the review session. Bye. Oh,